We're going to do 4-3 where we're going to do multiplication and division of fractions. So we're going to start by taking a look at a little scenario. David takes half of a cake and then he gives a half of this portion to a friend. So the friend gets a half of a half, or we know that that's a fourth of a cake. It's the equivalent to 1/2 times 1/2 because we know that of means multiply. We learned that when we were doing some translating. The product is 1/4. We know that of means multiply. So 1/3 of 1/4 means we'll be multiplying. 3/4 of 2/3 means we'll be multiplying. Here are the rules. To multiply fractions, we're going to multiply the numerators, or the top numbers, and we're going to multiply the denominators, which are the bottom numbers. And then if we can, we'll simplify the answer. And they've reminded us the same rules apply to positive and negative fractions as they do for whole numbers. So if we have the same signs, the answer is going to be positive. If we have different signs, our answer is going to be negative. So even if we have two negative, the answer is going to be positive. So let's do a little multiplying of fractions. We have 7/8 times 9/10. We're going to multiply the numerators and multiply the denominators. It's that simple. Here we have a negative times a positive, so we know our answer is going to be negative. We're going to multiply the numerators and we're going to multiply the denominators. There's our answer. Now we have a negative times a negative, so it's going to be positive. And we have 5 times 2 would be 10, and 8 times 3 would be 24. This is not in simplest form because they have a common factor. We can divide the numerator by 2 and the denominator by 2. So our final answer will be 5/12. This next example, we have a positive times a negative. Signs are different, so it's going to be negative, and we're going to multiply the numerators, 10, the denominators, 45, and we know we can divide both of these by 5 because they end in 0 and 5. So our final answer is going to be -2/9. So oftentimes in math, if we come across something a little bit new, then we turn it into something that we've done before. So here we have a whole number. We have a whole number times a fraction. So we're going to change that whole number into a fraction because we know how to multiply fractions by writing it over 1. So now we have 5/1 times 1/3. And again, we're going to multiply the numerators and multiply the denominators. We're going to change this whole number to a fraction. We'll multiply the numerators. 6 times 1 is 6, and the denominators. 5 times 1 is 5. So these are our final answers. Again, we have a whole number. We're making it a fraction. 10 times 4 would be 40. 3 times 1 would be 3. We're multiplying the numerators, multiplying the denominators. Again, we'll make the whole number a fraction. 7 times 10 is 70. 8 times 1 is 8. These are improper fractions. We can leave them like that, or, you can change them to mixed numbers if you want to practice that. To help us and make this simpler, instead of simplifying after we get our answer, we're going to do that before we do the multiplication. We just divide any numerator and any denominator by a common factor, by the same number. And this allows us to work with smaller numbers and gives us the same answer. So if we look at this, if we multiply the numerators, we'd get 20. If we multiply the denominators, we'd get 72. And you can see that those can be simplified. We can divide by 2. In fact, we could even divide both by 4. And we would come up with 5/18. Now, instead of waiting till the numbers are bigger, we can actually do that division, that simplification before we multiply. We can divide this numerator and this denominator both by 4, and we end up with a numerator of 5 and a denominator of 18. And you can see that's the same that we got if we waited till the numbers were bigger after we multiplied. So we're just simplifying before we multiply. Look at this next problem. We've got a negative times a positive, so our answer is going to be negative. And now we could go ahead and multiply and would have 35 over 110, but those numbers are bigger and they're harder to see common factors. So we're going to divide this numerator and this denominator by 5. And now we'll multiply the numerators and multiply the denominators. And if this were 21, we could simplify it, but it's not. So this is our final answer. Here we have 3 negative fractions. And when we have an odd number of negative factors, we know it's going to be negative. Or we can look and say that these are the same. It's positive. Now, the positive times the negative, they're different, so the answer is going to be negative. Now, I'm going to do some canceling here because if not, the answers are going to get big. The numbers are going to get big in the numerator and denominator. So I'm looking for on any numerator and any denominator that have a common factor. So I can divide the 9 and the 9 both by 9. I can divide the 6 and the 8 by 2. And now I have 1 times 3 times 7 would be 21. And 4 times 5 times 1 would be 20. So here's our answer. And if we actually multiplied these, they would be very big. We have 2 negatives, so this is going to be positive. Now I'm going to cancel any numerator and any denominator. How about 7 and 21? We can divide those by 7. 8 and 4 we can divide by 4. 9 and 27 we can divide by 9. So now we have 1 times 2, 1 times 1 times 2 would be 2, and 3 times 1 times 3 would be 9. So there's our answer. And again, those numbers would be big if we went ahead and multiplied everything. We have a whole number, so we know how to do that. We just talked about that. And now we're going to look for canceling. We can divide 24 and 8. It's a numerator and a denominator by 8. And we have 3 times 3 or 9 over 1, which is the same as the whole number 9. This would be an okay answer for me. This is what you'll find in the back of the book. Okay, the next one, we have a negative times a positive, so our answer is going to be negative. And we'll make a fraction out of the whole number. 5 and 100, we can divide both of those by 5. So we have 20 times 2 would be 40, and 1 times 1 would be 1. So our answer is negative 40. Now, if we have letters, we can do the same thing. Same thing would be multiplying the numerators, multiplying the denominators, and then simplifying. Or we can do that simplification in the form of canceling before. So I see the 8 and the 4, I can both divide by 4. And now I have 3x and 5x, and I can divide both of those by x. So those cancel out. We have 3 times 2 would be 6. 1 times 5 would be 5. There's our answer. Now this one looks a little different because we have exponents. We know that x squared is x times x. Y cubed is y times y times y. So now let's take a look. Mark those out because we're not looking at those anymore because we have the same thing expanded up here. I'm going to divide this numerator and this denominator by x. And I'm going to divide this numerator and this denominator by y. So I have x times y for the numerator and 1 as the denominator. So this way to write this with exponents would be x, and then we have 2 factors of y, that's y squared. When we work with fractions and they have exponents, they're the same thing. 1/4 squared would be 1/4 used as a factor twice. Multiply the numerators, multiply the denominators. 1/4 cubed would be using 1/4 as a factor 3 times. So 1 times 1 times 1 is 1. 4 times 4 is 16 times 4 is 64. 2/3 squared would be 2/3 times 2/3, or 4/9. 4/5 cubed would be 4/5 times 4/5 times 4/5. This exponent of 3 means we're using the base 4/5 as a factor 3 times. 4 times 4 is 16 times 4 would be 64. 5 times 5 is 25 times 5 is 125. So 4/5 cubed would be the same as the fraction 64 over 125. Now we're going to get into a little geometry. They're kind of plugging this in as we go along. Most of you know that the area of a rectangle is the length times the width, and this is our formula. And when we find the area, we're finding out how many squares there are in this figure. We're filling the space in the middle with squares. So today we're going to look at the area of a triangle, and we know that the triangle is half of a rectangle. So we're building from that. We're not going to go into the specifics, but the formula for the area of a rectangle is this: 1/2 the base times the height. The base is one side, and the height is the shortest distance from the opposite vertex or point, which is perpendicular to that side. So we have the base times the height. Your sheets may be divided a little differently than this. This is kind of the new version with page numbers actually at the bottom now. So the value of B measures the base of the triangle, any of the sides, it doesn't matter which one. The value of H is the measure of the height of the triangle. And once you've chosen the base, the height must be measured as the shortest distance, which is of course perpendicular, from the base to the opposite vertex or to the opposite point. So what we have here are 3 identical triangles, and we're just showing you that if you chose this side as your base, then the height would be this opposite vertex, the distance from the side to that vertex. If you chose this as the base, this would be the opposite vertex, and this distance would be the height. You get the same answer. So if this is what you've chosen for the base, then this is the opposite vertex, and this will be the height. So we got a couple to do here. Obviously, this is the base, and this is the opposite vertex, so this would be the height. So when we do these problems, we're going to do 3 things. We're going to write the formula, and now we're going to substitute. You know, this is multiplication because there's no operation sign in there. The base is 14. The height is 8. So we're going to multiply those. So if you want, I'll just do this. I'll just do this down here where you can actually see what I'm doing. These 2 whole numbers I'm making into a fraction, and now I'm looking for cancellation. I can divide either of these by 2. I'll just do the 7. I'll just do the 14 and get 7. So now we have 1 times 7 times 8 would be 56, and 1 on the bottom. So our answer is going to be 56, but we need a label. Since this is measured in centimeters and we're talking about little squares, we can call them square centimeters, either that way or we can write it this way. This is just a quicker way to write it, but that's our answer. So if we divided this into little centimeters, little square centimeters that are a centimeter on each side, then we could, this one's a little large for the way the scale of the drawing, but we'd be finding how many of these are in here. And as you can see, there would be partial squares, and so arithmetic is taking care of that for us. The other triangle that we have, this is the side we're choosing as the base, and we want the distance from this opposite vertex to this side, and we know that that's going to be a perpendicular distance, and so they just extended this, so 2/3 is the base. So now as we find the area, we're going to write the formula. We're going to show the substitution. B is 2, and the height is 2/3. And what we know is we're going to make that whole number a fraction, and we'll figure out what the area is. I'm going to multiply this times this times this, and I'm looking for cancellation. I can divide either of these by 2, but only one of them. So I have 1 times 1 times 2 would be 2, and 1 times 1 times 3 would be 3. So the area is 2/3. And what kind of squares do we have here? It's measured in feet, so we'll either have square feet or we will have square feet. Be sure this exponent is squaring the unit, not the number, because the number is 2/3. It's not 4/9, it's 2/3. Okay, so we do all three of these things. Write the formula, show the substitution, and then label the answer one way or the other. It really doesn't matter. We're getting ready to do division of fractions, and there's one vocabulary word that we need to establish, and that is reciprocals. Two numbers whose product, that means when you multiply them, when the answer to that multiplication problem is 1, those numbers are reciprocals. So if we have 3/8 times 8/3, we have 24 on the top and 24 on the bottom, and that's one whole. And as you can see here, we've just flipped the fraction. We've just flipped the fraction. So that's what the reciprocal is. So we're going to take a look and kind of justify what we're going to do for our algorithm or our rule here. If you divide 6 by 2, either like this or like this, you get 3. And if you multiply 6 by 1/2, making 6 a fraction, you also get 3. This would be 6/2 or the whole number 3. So dividing by 2, which we did here, is the same as multiplying by 1/2. And what we know is that 2 and 1/2, these are reciprocals because we've just flipped one over to get the other one. And if we multiplied them, we'd get 2/2, which is the same as 1 whole, which is what our definition says. So here's the rules of the algorithm for dividing fractions. We're going to change the divisor, the fraction to the right of the division sign, to its reciprocal. In other words, we're going to flip number 2. And then we're going to multiply the resulting fractions, and if we can, we'll simplify the answer. So we have some problems here. 1/2 divided by 1/7 is the same as 1/2 times the reciprocal. We're going to flip number 2. So then we're going to multiply. 1 times 7 would be 7. 2 times 1 would be 2. 1/8 divided by 5/9 is 1/8 times the reciprocal. So once we're in multiplication, we're going to multiply the numerators, multiply the denominators. 2/3 divided by 3/5 would be 2/3 times the reciprocal. We'll flip that second fraction. 2 times 5 would be 10. 3 times 3 would be 9. 7/8 divided by 4/5 would be 7/8 times the reciprocal. So we're flipping this one. And we have 35 on the top, 32 on the bottom. This is pretty simple. You have to know the rule, and then it's pretty simple. Now, if you remember back in multiplication, we did the canceling, and that made it a lot simpler in the end. So we can do it when we're doing a division problem, but we can only do it in the multiplication part. We can't do it while we're in division. We can only do it in the multiplication. So we'll take our division problem and change it to a multiplication. We're going to flip the second one. And now, once I'm in multiplication, then I can cancel. So I can divide the 10 and the 5 by 5. And I have 8 on the top, 3 on the bottom. 8/3. 3/4 times the reciprocal. And again, now that I'm in multiplication, I can cancel. I can divide this numerator and this denominator by 4. And I end up with 6/1 or the whole number 6. And either one of those is fine with me. This is the one that'll be in the back of your book. This one would be okay with me as well. Okay, 4/7 divided by 20. We'll make it a fraction. So 4/7 times the reciprocal. We'll multiply the numerators and multiply the denominators. Oh, and this one, we could have simplified it over here. If we divided 4 and 20 by 4, we would have had 1 on the top, 35 on the bottom. And that's what we would get here if we divided both of these by 4. We would get 1/35. And as you can see, dividing 140 by 4 is more of a chore than it is to divide 4 and 20 by 4. Okay, we'll make this whole number a fraction, and we'll multiply by the reciprocal. And I'm going to cancel. I'm going to divide this numerator and denominator by 5, and I have 8/1, or the whole number 8. Okay. Same thing is true when there are variables involved. We're still going to make this whole number, so to speak, a fraction by placing it over 1. And instead of dividing by it, we're going to multiply by the reciprocal. Now what we know is that this is really 3 times x times x, right? So we can divide this numerator and this denominator both by x. So those cancel out. And we have 2 on the top, 2 times 1, and on the bottom we have 3 times 3 times x, or 9 times x. Okay, this next one, there should be an x in that blank space. So we have 10x squared over y squared, and we're going to multiply by the reciprocal. Now, we know that this is 10 times x, so I'm just going to write that up here. You don't need to do this, but if you can't see it, that might be good. And y squared would be y times y. So now I'm looking. I can divide this 10 and this 5 by 5. And I can divide this numerator and this denominator both by y. And I have 2x squared on the top. And on the bottom, I have a y. Okay, what I know about this is that it's going to be negative because we have different signs. This is going to be 8y squared over 7 times the reciprocal, 5 over 4y. I know that this is 8 times y, so I'm just writing that out. You don't need to if you don't want to. And now I can divide the 8 and the 4 by 4. And I can divide the y and the y from the numerator and the denominator. They cancel out. Now I have 2 times y times 5 on the top, which is 10y, and I have 7, 1 times 7 on the bottom. And we said that was going to be negative. Got to watch that. So this is really the answer, not this positive one.